Hi everyone, this is lecture 3.1 in which we will talk about research methods. So first we'll talk about why we study society with science, then we'll talk about what exactly research is, then we'll talk about scientific method, the scientific method itself, and then we will talk about specific research methods. Most people think that they're very knowledgeable about how society works. You're not going to encounter this class, for example, for most people until you're at least 18 and enrolled in a college class, maybe a little bit earlier if you're an accelerated student. So in that 16 years of time, you've had 16 years of exposure to society. However, you haven't studied it scientifically. You haven't collected your knowledge through science. And science is designed to produce accurate information, right? It is not produced to entertain you. It is not produced to win political arguments, right? It is produced to produce truthful knowledge. Thus, that knowledge you have about society, not all of it, but some of it, may have been corrupted, if you will, if you want to be dramatic about it, by things that are not science. It may be flawed in some way. Now, many people hold beliefs that people that are inaccurate, right? Or you might think you have accurate information. I certainly have had what I believed was accurate information that has been disproven later by scientifically accurate information. And that's a really frustrating thing. And a lot of people, we have these things. So examples of these are conceptions of drug use among African Americans versus white people. There's a perception that African Americans and the African American community has greater problems with drugs and addiction than the white community or anyone else in the United States. The reality of the matter is that all populations, going across racial groups, ethnic groups, gender groups, have issues with addiction and chemical dependency. Where the nuance comes in, and when people don't quite know what they're talking about, they often are flawed in terms of nuance, is that different populations do use different drugs sometimes. Not always, but sometimes. So, for example, in the 1980s, the African American population in inner city areas had a very serious problem with crack cocaine. However, white populations during the same era also had similar usage of powder cocaine. We'll talk about how that was a social problem, the difference between those two drugs when we talk about race and ethnicity. But the reality of the matter is that both populations had issues with addiction during that era, but how that played out turned out to be different, and it turned out to be different largely in terms of the privilege that white people had over the privilege that was denied of poor black people. Similarly, people think they know quite a lot about the causes of homelessness. There's a common misperception that homeless people are either lazy or deserving of their situation. The fact of the matter is that many homeless people are unable to change their lots. They may have mental illness, they may have serious addiction issues that that's what got them in that situation, or they developed addiction after they became homeless. Another misperception about homelessness is that it's always been with us. That isn't really true. There have been, some homeless people now and then in previous eras. But prior to the 1980s and late 70s in the United States, we didn't have homelessness the way we have homelessness now. There were very specific political decisions that were made and policies put into place that they weren't trying to make homeless people. They weren't trying to make people homeless. But the ramifications of those decisions created the current crisis that we have with people being homeless. Similarly, people, to go with another belief that people have, is that if you get an education, then you will automatically be able to succeed. This isn't as strong as it used to be, but it still is something. The fact of the matter is that if you are disadvantaged in our society, then getting an education might help you some, but it isn't going to put you on an equal footing with someone that has all the privileges in the world. Those are just three examples. I often say in sociology that sociology is a bummer, and this certainly is. Those three facts are certainly three. Now let's talk about the difference between a hypothesis and a theory. Our language is fuzzy. Our English language, we often talk about theories when we mean just maybe a dumb idea, but we often are talking about in terms of hypotheses. So a hypothesis is an idea about the world which can be disproven when tested against observations. Usually in our language, when we are talking about theories, we're really talking about hypotheses. So if I say that if you go out drinking all night, that you will get a hangover. Well, that's a hypothesis. It's not a great hypothesis, but it's a kind of hypothesis. It is based on my previous observations. People who have gone out drinking alcohol all night, in the morning have certain illness, that is largely tied with alcohol toxicity in their body and partially tied to dehydration. We call that a hangover. So I could test that hypothesis. I could gather up a bunch of people, half of them drinking alcohol, the other half, let's say, would drink an equal amount of water the night before, and then we could test what that meant to their bodies in the morning. That's a hypothesis, testable. A theory, on the other hand, is set. A theory is a fact. A theory is a law, right? Now, scientists, we are creatures of nuance, and unfortunately, we are not a society of nuance. We don't really like listening to the details of things in our society. So when scientists say, well, I mean, of course, a theory can be disproven, but, well, that's when most of us stop listening, right? So it's like, well, it's just a theory, be disproven. So, evolution, it's just a theory. It's an idea that doesn't mean anything. That's not what the scientist is saying. That's not what the biologist is saying. What the biologist is saying is, we have overwhelming evidence to show that evolution via natural selection is reality, right? We have overwhelming evidence to show that. We have overwhelming evidence to show that if you drop an object, it falls to the earth, and we call that gravity. Gravity is a scientific theory, right? It's not just a theory, right? It falls toward the ground, right? That sound was my hands hitting together, right? That's what a theory is. A theory is a scientific fact. You can call it that. It doesn't give it the nuance that many scientists would like to give it, but if we're going to use the blunt language that we like in our society, then that's what a theory is. Now, to go back to hypotheses, every hypothesis, and therefore every theory too, has an independent variable and a dependent variable. An independent variable is the variable that causes change. It exists on its own. And a dependent variable is the variable that is changed, and it is dependent on the independent variable, or how it does its thing, or what it does is dependent on the independent variable. And that's very abstract, and if you've had some trauma with math in the past, this might be like sounding like buzzing in your ears. So let's give a more accurate example. So for example, my hypothesis could be black men and white men, that's my independent variable, whether you're black or white, are treated differently when pulled over by police officers. So my independent variable there is black men and white men. We're not talking about Hispanic men. We're not talking about Asian men. We're not talking about black women or white women. We're talking about black men and white men. That's the independent variable. And dependent variable, treated differently when pulled over by police officers. What exactly do we mean by differently? Well, we would have to suss that out before really testing the hypothesis. That would happen later in our when we talk about the scientific method. But this is not a great, but an okay hypothesis, right? So the independent variable, if you are black, you are treated one way. If you are black, independent variable, treated one way, dependent variable. If you are white, independent variable, treated another way, dependent variable, right? Being black or white causes how you are treated. If you're interested in specifically treatment of black people and white people dependent on race, there's a really amazing paper written by Dr. Ludman and Dr. Kaufman in the year 2003 called Driving While Black, The Effects of Race, Ethnicity, and Gender on Stops and Police Actions. Really a pivotal work in the field. It's more than 15 years old now, but it's an amazing work. So in our hypothesis, we are trying to identify positive causations, or if we can't identify positive causations, we want to look at it either a correlation or negative causation or negative correlation. Let's talk about those. A positive correlation or a positive causation is a relationship showing that one variable rises or falls when the other does as well. So for example, obesity rates increase as poverty increases, right? That is a positive relationship. So as one goes up, the other goes up. That statement doesn't really say what the independent variable or dependent variable is. Thus, it's a correlation. If we can identify the independent variable and the dependent variable, then we have causation. I'll talk about that more in a bit. Negative correlation then is as one variable increases, the other decreases. So as one goes up, the other goes down, or vice versa. So, for example, marriage rates decrease as male unemployment rates increase, right? So marriage rates go down as unemployment rates increase, right? People don't want to get married to men when they are unemployed. Interesting, very interesting. And that doesn't mean that the man is undesirable. It might be that the two people in the relationship are going, maybe we shouldn't have a wedding right now, or whatever, right? Because we can't really afford it. It doesn't mean that if you're unemployed, people don't love you. That's not what that means. But let's talk about correlation and causation a little more specifically, because we may have jumped the gun there in that previous slide. There is a relationship between two variables. That's what correlation means. So we know there's a relationship between the two things, but we don't know what causes what. We can't identify that independent variable and that dependent variable. For example, children who watch too much TV are more violent. That's the beginning of a hypothesis, and we could have data that show that. I'm not convinced of that, but that would be, if that's what the data shows, then that's what the data shows. It's unclear, right? We don't know the nature of the relationship. Are children being driven to violence by watching TV? So in that case, it would be watching TV creates violence, or do children who are inherently more violent, are they more inclined to watch more TV? Right? So in that second case, it would be you're already violent and the person that's already violent loves to watch TV. That's not usually how we think of it when we do think of it in these terms, but it could go either way depending on what the data shows us, the numbers. Well, usually the numbers. Anyway, causation then is when it's clear that the independent variable causes a change in the dependent variable. For example, high salt intake causes high blood pressure. It is a medically proven and clear relationship that the more salt you eat, the greater your chance of developing high blood pressure. That doesn't mean that everyone that eats a lot of salt has high blood pressure, but it does mean that statistically you are more likely to develop high blood pressure if you consume a lot of salt. This is a proven causation. It's a causation I don't like because I really like salty foods and my family has a history of high blood pressure. One of these days I have to stop eating as much salt, but that is what it is. Science isn't always what you like. I want to drive home, though, that correlation does not equate causation, right? Just because there's a relationship between the two variables, or it looks like there's a relationship between the two variables, doesn't mean that one makes the other. Children who watch too much TV are more violent. We don't know the nature of that relationship. We simply don't have sufficient data there. At least not in front of us. Let me know if you have questions on that. That's an important concept. So let's talk about validity and reliability. This is another thing we're trying to establish in science. Validity are concepts that the concepts and measurements are accurately represented when they claim what they claim to represent. Thus, our observations are adequately reflect the social world. So, examples of this are crime, police reports, and the National Victims Survey. So, there are people who question the validity of police reports. Are the police actually reporting crime the way it actually is? Does the data police present, is that accurate? Well, there's a thing called the National Crime Victims Survey that is independent of police reports. And the reason why we have that isn't because we inherently distrust police as a society. Some people distrust police, but as a whole, I think most people probably do trust police. But we have this National Crime Victims Survey to double check it, just to make sure, so we can more accurately trust police. And if we find an area where police are not accurately reporting a thing, we go and we, maybe retrain the police and help them do their jobs a little bit better. So that would be a use of validity, a use of, keeping things on track. Reliability, then, is the extent to which findings are consistent with different studies of the same phenomena or the same study over time. So we not only are interested in the measurement of the thing at that moment, but we want to be able to measure the thing over a period of time. So going back to our police example, maybe there was a particular problem in a given jurisdiction where, I don't know, maybe the paperwork the police were using were unclear and it was causing the data to come back reporting crime at an increased rate. Well, and then they got that paperwork fixed and it went down, right? So the data at that time would be inaccurate. It would be unreliable. But over time, that they fixed that and increased the reliability. Yeah, that's an okay job. That wasn't a great example, but I think it did the job. Most sociologists believe that they should not allow their personal beliefs to influence their research. This is an idea that was first formulated by Max Weber. He observed that social scientists, we can have a tendency, because we are human beings that live in a social world, to put our opinions in things. Weber called this concept, though, that we shouldn't put our opinion in things value-free sociology, stating that researchers should identify facts without allowing their own personal beliefs or biases to interfere. Now, you may remember when we talked about Marx that he said that the reason why academics do their work is to pursue social justice and to make the world a better place. This could be seen as being at odds with value-free sociology, because if we are putting our concepts aside, if we're putting our values aside, then we're not doing praxis, maybe. And that's the only way to do actual scientific sociology. Now, the general consensus within sociology is that these aren't incompatible ideas. Some people believe that, but the reality of the matter is that you can do, and this is how many sociologists do their work, that you present the facts, that you report on the facts, that you study the facts, and then after those facts are gathered, the way you share it with people, once the reality is gathered, the way you share it with people, the way you teach it, whatever, as long as you are still reporting the facts, if you use it in an activist sense, then that's okay, as long as you are still presenting the facts. As long as you're not manipulating the facts, but you're just sharing accurate information with people, then that is okay. That is a way you could praxis, there's a tongue twister, while still doing value-free sociology. But there certainly are social scientists that believe that you shouldn't do praxis. Now, just like theories, the word theory, we also don't really, as a society, understand research all that well, right? So the theory v. hypothesis, I don't know why maybe I did talk about that in lecture 2, I don't know. So research doesn't mean what you think it means, maybe. It depends. It depends how scientifically minded you are and how well you've been trained. Maybe if your parents are chemists, they drilled this into you, but most of us haven't. Most of us think that going to the library and reading about something, or Googling something, or listening to the radio and learning about something, that is research. When scientists talk about research, that's not research. That's not what that means. That's learning, right? You're learning about a thing. If you Google search the facts of Michael Jackson's life, for example, you're not doing any research. You're just learning things yourself. Research, let me look at the next slide. Oh, yeah, this is what research is. It's not Googling, then what is it, right? Research is the creation of new knowledge. If you're finding something that no one else has ever found before, that is research, right? So if you are counting the number of people in the United States of America through some sort of innovative channel, and you're being highly accurate in some way, then that is research. If you're counting the number of leaves on your personal house plant and nobody else knows that, then that is actually research. It might not be relevant research, but it is research. You are creating new information. You're finding out something no one else has ever known before. But to do research scientifically, you must use the scientific method and a research method. I'll talk more about those later. Now, some examples of not research would be watching the news, or going to the library, or looking up something on the internet, right? Those are learning. You're certainly doing some learning, but you're not researching. Examples of research would be conducting a survey, or conducting an actual experiment using experimental research models, or doing field observations. All of those are scientific methods, different than the scientific method, but scientific methods that are used to gather data. I'll talk about those more later in this lecture. But let's talk about the scientific method. The scientific method is a procedure for acquiring knowledge that emphasizes collecting data through observation and experiment. Really, I feel that the scientific method should be called the scientific procedure, namely because it's not actually a research method, it's a procedure. But as I say so many times, our language is clumsy. These are the stages of the scientific method. First, you do your literature review. So you do that learning, right, that we often call research that isn't actually research. Maybe you do a quick Google search, but after you do that quick Google search, you read the relevant news articles on the topic, and then you read the academic journal articles on the topic, which as a researcher, that means more to you. Then you develop your hypothesis. You develop your statement of independent variable versus dependent variable. Then you determine your variables. So using our hangover example, if you drink too much, then you will have a hangover. Well, drink too much, IV, hangover, DV. Then you determine your operational definition. So you pick apart that independent variable and dependent variable. If you drink too much. Well, what do we mean by too much? Is that 2 beers? Is that 4 beers? Is that 12 beers? Right? What's too much? Is it too much for me? I am 6'4" tall, approximately 200 pounds. My too much would be different than someone who's 100 pounds, and I'm relatively healthy, so my too much would be different than someone with, say, liver disease, right? What we would have to determine what we mean by that too much. We would have to determine what we mean by have a hangover. Do we mean what could be called a severe hangover? To get gross, is puking involved? Is a headache involved? Is the inability to move really without pain? What do we mean by these things? We got to get as specific as possible with our hypothesis. Then we collect data. So how would we collect this data? Would we break into 2 groups, maybe have 100 willing participants? We give 50 of those people alcohol, a certain amount of alcohol one night, and then 50 of those people the same volume of water, right? And then we have them go about their evening, and then when they wake up in the morning, we gauge the results, right? That's how we could collect some data. We interpret those results, we share them with the populace, and that's where once we interpret those results and we share, after we've interpreted and the sharing, that's where that concept of praxis could come in. And we share the really earth-shattering news that if you drink too much, you have a hangover, which is something most people who have drank even a little bit know. But yeah, that's generally how that would work. Here is a graph that I won't dwell on for too long, but each of those ovals includes a stage of the scientific method, and it really explores the fact of the matter that science is fluid. The scientific method is fluid. We don't always do it in 1, 2, 3, 4, 5. Sometimes we might start with collecting data. We might start with just, poking around in the literature, and then we develop our hypothesis, or we identify the problem, right? So it's a fluid thing, the scientific method. Now, why do we do the scientific method? There are a lot of reasons. But the reason why we do the scientific method is to prevent flawed logic. One example of flawed logic in science is called a spurious correlation. So this is a relationship that seems to appear between 2 variables, thus a correlation, but it has been caused by some external or intervening variable. Or that's a slightly flawed definition. Or it's just a pure coincidence, right? So number of people who drowned in falling into a pool correlates with films Nicolas Cage has appeared in. This is interesting, isn't it? And it appears that as Nicolas Cage has been in movies, then more people are drowning in swimming pools. This particular spurious correlation does not appear to have any obvious intervening variable. It is purely a matter of coincidence. And this is why we state that causation does not equate, that correlation does not equate causation, is because sometimes it's just weird coincidence. So now let's talk about types of methods. So there are different ways to collect information about a topic, but each method has benefits and limitations. When beginning a research project, it's important to consider which method you will work with, and hypothetically, it's best to pick a method that will match your project. Now, with that said, most social scientists and most scientists in general have their preferred methods, but the reality of the matter is they could probably be a little bit more flexible than they actually are, but we try not to tell anyone about that. So the research methods described in this chapter are often applied outside the field of sociology. I just want to mention that because sometimes psychologists use these methods, sometimes anthropologists use these methods, economists use these methods. I've known English professors that study English literature to use some of these methods, which I find intriguing. There are two general types of methods: quantitative research and qualitative research. Almost every method can fall into either quantitative or qualitative research, with some research methods falling into mixtures of those two. Those are called often mixed methods. Quantitative research translates the social world into numbers that can be studied mathematically. And that is often favored in sociology. Qualitative research then uses non-numeric data, such as texts, interviews, photos, and recordings to help us understand social life. So one qualitative method is ethnography. It is used to collect data by observing people in their environments in order to understand the meaning that they give to their activities. So we are watching people in what you could call a natural setting. That's what they would do. So we would go to a bar and watch people behave. We would try to be kind of subtle about it so that they don't actually catch on that we're watching them, because then they would change their behavior. That's ethnography. Ethnography typically occurs in two steps. The researcher participates in and observes the setting, and then the researcher makes a written account known as field notes on what goes on there. So the researcher goes to the bar, tries to be unobtrusive, might take a couple little notes in a notebook, but once the researcher leaves the setting, then they write down their copious field notes. One type of ethnography is known as participant observation. In participant observation, the researcher both observes and becomes a member of the social setting. So instead of just going and observing the bar, I'm having a lot of alcohol in this lecture apparently. I'm not drinking, but I'm talking about a lot of alcohol. Anyway, the participant goes to the bar, and instead of just watching the patrons at the bar, maybe the researcher will get a job behind the bar, either as a bartender maybe, or as someone washing the dishes. And if you would do that, you would get a different understanding of how the bar works than just someone sitting in the bar. Another type of qualitative research are interviews. And interviews are pretty much exactly what you think they are. They are direct face-to-face contact with respondents. Interviews can generate massive amounts of qualitative data, and they can be done over a prolonged period of time. I actually, in my recent research over the last couple of years, I've really favored interviews because they're a really super flexible research method, and they can get so much information. Just one interview can get pages and pages of good information. This last little bit on the end of this slide should probably be its own slide. Any researcher for any project usually identifies a target population of interest. Those are the total people that want to be studied, the group of people, the specific group of people that want to be studied, and then they select a sample population of people to be interviewed from that population. So if I want to study Latino women living in Cincinnati, Ohio, I couldn't possibly interview all of the Latino women living in Cincinnati. So I might be able to interview 1,000 if I'm really ambitious. The total population of Latino women in Cincinnati would be my target population, and then the Latinas that I actually am talking to, those would be my sample. Interviews can use open-ended questions or closed-ended questions. Open-ended questions let respondents talk as much as they'd like. You can really get into some really interesting territory, but you do need to have some discipline there to make sure that the interviewees don't start talking about things that are completely irrelevant. Whereas closed-ended questions give respondents a choice of answers that are, they're closed-ended. So, like, it doesn't make sense to ask something like, you can't ask, how old are you? That is closed-ended. There's an absolute number associated with that. Surveys are a quantitative method. So surveys are questionnaires that are administered to a sample of respondents selected from a target population. Survey research tends to look at large-scale social patterns and employs statistics and other mathematical means of analysis. We are, in our modern era, probably most familiar with surveys as they pop up on social media or the internet in some way. The What Harry Potter House Are You survey is, I suppose, a survey. It's not super scientific, but it is a way of gathering data. It's an example. It's not a great example of a scientific survey, but it is an example of a survey that could work kind of like that. Existing sources refer to using any data that has already been collected by earlier research and is available for future research. So the US Census is a good example of existing sources. So the census, by virtue of the Constitution, is gathered at least every 10 years, and that is pretty good, reliable information. We know it's going back, I think, to at least 1780. We have a certain amount of information about the people that live in the United States. Market research data can also be useful, but when dealing with organizations that have an agenda, such as a corporation, you have to be concerned with why they ask certain questions, but it could be useful. Other sociologists are a great source of existing source data. Experiments are another form of a method. Experiments are often qualitative, but sometimes quantitative. They are formal tests of specific variables and effects that are performed in a setting where all aspects of the situation are controlled. As I've said before, experiments are less common in sociology, namely because as sociologists, we tend to think that we really need to take all variables. We need to live in the real social world. So as such, many sociologists don't really think experiments are good to be done, namely that they're not really that valid, if you will. However, some sociologists do use experiments. If you are going to do an experiment, you must have an experimental group and a control group. An experimental group is one in which participants receive the experimental treatment. So in our alcohol hangover hypothesis, the group that actually consumed the alcohol, they got the treatment of drinking too much alcohol. The control group was participants that continue without intervention so that they can be compared to the experimental group. So if our control group in that example would be people that drank an equal amount of water compared to alcohol. It could be, hypothetically, that the illness was caused by drinking too much water. Or it could be that the entire 100 people were infected with the flu, right, before they came in. We wouldn't be able to rule those things out without a control group. So that's what that would kind of look like. Okay, that is it for this lecture. I hope it hasn't been too long or too painful for you. There is another lecture following this, but if you have any questions in the meantime or with what's happening, please let me know. Thanks.